my blockchain, of the Ethereum blockchain, right? Of the meaning all the blocks, all the data, it will have everything with it. Now, why should you have? What is the use of being a full node? When you have the full node, you will be able to validate the transactions, validate the blocks. Okay, because we saw that consensus mechanism of proof of work, right? Where one miner will build the block and other nodes will confirm the blocks, right? So to confirm the blocks, um, you should have the full list of the blocks till now. Then only you can confirm, right? So by being a full node, you will be taking part in the verification of the blockchain, right? So this being a full node is not compulsory, right? If you can even choose to be a light node. Okay, what is a light node? You may not be having the complete details of the blockchain, so in that case you will not be able to verify the blocks, but yes, you can be part of the blockchain. You can initiate transactions. You can it can be a simple mobile wallet application which is pertaining to just initializing transactions pertaining to yourself, that you can do. Okay, that is called as a light node. And then there is something called as archive node, right? What is this archive node? Is you can have a node dedicated for querying purpose, because it will have the complete historical data. It will have a software that will traverse through this blockchain and it's what if I'm having an application which is looking for this transaction went into which block, how do I find out, right? So then I need a dedicated software which is going to query the blockchain and find out where in which block and all that, right? That activity, for that activity I need the complete historical data of all my blocks, right? So then I can choose. Generally in a large network, this will be a requirement, because it's like how you have database queries, right? So when you have a large application built on Ethereum network, you will be needing such kind of querying or reporting needs. For that we need to design an archive node. So when you are on a Ethereum network, you can be either of these three types. And it is totally up to you. No, there is no compulsion that you have to be one of the one, you should be a full node or you should be an archive node. It is totally on the purpose of your node that is existing on the network. But of course, the functions that you can perform will be limited to what kind of node you are. If you are a light node, you obviously cannot verify the transactions. If you are an archive node, then you should concentrate only on the reporting, otherwise the node's performance will be very less. So like that, the functionalities has to be decided based on what you require. Okay. Now, how will this nodes all talk to each other, right? When I'm saying transact, that means I should have something to transact on, right? Because when I am transacting, when I am initiating a transaction, obviously I should also have means to pay for the transaction. Otherwise, I am not going to be able to do the transaction at all, right? So there are some things called as accounts. Okay, if I have to give you an analogy for easy understanding, this is like our bank account. Okay, so our externally owned account is like a wallet which is going to hold ether balances. Okay, that is where your um, uh, cr- uh, cryptocurrencies are going to be stored. Now every externally owned account, how will you identify? Like how we have account number and there is a password attached to it, right? So like that, here we have some things called as private and public keys. Okay, so every account, externally owned account, has a public key which is going to be known by everybody. So if you have to initiate a transaction, you will say I am initiating it from my account with the public key. Now how will I authenticate that transaction? I should give the permission, right? Otherwise, without any permission, can amount get detected from your bank account? It cannot happen. So without a valid password, that cannot happen. So that is where we have the private key. So the any account is identified by this key pair, public and private key pair, then only the public key is used for others to address you, and the private key is for you to authenticate for any transactions that you will initiate from your externally owned account. Now there is a different type of account which is called as contract account. So whatever smart contract, yesterday remember I deployed that smart contract onto the remix dummy environment, and I did the transactions. Now what do I mean by deploying is I am creating a contract account that is also going to have an address. Okay, it can also hold ethers, because I said in the smart contract, in the escrow example that we took, we said the buyer also has to deposit some money, ethers. The seller also is depositing. Now where are they depositing these ethers? It is going to stay in the contract account. That is the account controlled by the smart contract program. Okay, so it will also have ethers, but additionally it has the code, the smart contract program that we are writing, right? That is also going to reside in the account. Okay, in the sense the compiled version of that code. Okay, the byte code is what is going to reside in the contract account. So whenever we are talking about calling a smart contract, it means that we are executing that code in that account. Okay, so the based on the interactions and everything, this contract account can further initiate additional transactions. Like for example, yesterday when we said when the contract is complete, we transferred the ethers from one account to the from the contract account back to the buyers and the sellers accounts, right? So transactions can be we calling the confirm no yeah confirm delivery method is one transaction, but for that transaction to be complete, inside that method what we had written transfer back the money to the buyers and the sellers account. So this is one transaction. From that transaction there are two more transactions which got initiated. So that is possible when we are having a contract account. Okay, so these are two basic types of accounts that you can have in any Ethereum node. Okay, so and when I say an account, whether it is a contract account or externally owned account, these are the four parts of that account, right? That is how it is going to have in the memory. Okay, so it has a balance which is going to tell me how much is the ether balance. Okay, there is a nonce which is going to tell how many this nonce is like how many transactions were initiated from this account. That is what this is going to give. The storage hash is to whenever there is a contract account, right? The code hash will contain the byte code, EVM byte code that is going to get executed. Now for this byte code, it has some memory, right? We said this is the buyer, this is the seller, this is the price. So somewhere this has to be stored. That is going to be there in this storage hash. Okay, so basically any account is going to contain these, but then it will be used or not used depending upon the type of account. Okay, if it is only externally owned account, then this code hash and all will not be there. It will be empty, but balance will be there and nonce will be there. But if it is a contract account, then this code hash space also will be utilized to store the byte code. Okay, so like that, the different types of these are the two different types of accounts that you will be using whenever you are working on any Ethereum node. Okay, so like I said, the transactions can be initiated only from an externally owned account. Okay, no contract account cannot initiate something on its own. But for it to initiate, the original transaction has to have come from an externally owned account only. The contract account cannot automatically initiate a transaction like that. Okay, so externally owned account only will initiate the transaction first to the contract account, then the contract account can internally split into other transaction accounts to either an externally owned account or to another contract account. That also is possible. Okay, so this is the basic fundamental of an account. I will show you how you what do you mean by really a externally owned account and what is a contract account. We will see that today. Now when then we said we have this transactions, right? What is this transactions? Transactions are nothing but the way in which two nodes are going to talk to each other, which will which may or may not change the state of the um, chain, state of the network. Okay, so this transactions, um, sorry, which will change the state of the network, not may or may not, it will change the state of the network. Okay, so recipient is nothing but who's at the receiving end of the external of the transaction, whether it is an externally owned account or is it a contract account, that is the recipient. And then you have to sign, see a sign means who's initiating the transaction has to sign the transaction, that the sender has to sign the transaction. Why, what does the sign mean is I have to give the authentication to perform this transaction. So like for example, I am initiating a transaction from account transfer of so many ethers from my account to another account. Now I have to sign my transaction with a password for my account. Only then the transaction fee and everything can be taken, right? That's the way of how I am going to, it is like how we sign a check, right? If we don't sign the check, then the check is void, the transaction cannot happen. So here also, for every transaction you should have an signature sent along with the transaction from the externally owned account. And then what is the value? Are you transferring some ether to, or are you paying something to the contract account? Yesterday we said we have to send the deposit money, right? So that is the value that we are sending with respect to the transaction. And then are there any data? The data in the sense, we yesterday we saw the we saw who's the, we initiated the contract with buyer and then the seller, right? That is called the data that is there in the transaction, sorry, in the contract. So that data is what is going to get stored in this storage hash component of your account. Okay, and for every transaction you need a gas, you need the transaction fee also, right? So we need to mention the gas limit, which is the number of units of gas, and then the fee for that, per fee per unit of gas, that is called as the gas price. So all these are necessary components of your transaction. So what you see here in the left hand side is a sample transaction initiated, and what you see here is a response that you will get as a transaction. So when I so look at this, why I'm initiating a transaction from this account to this account, okay, and I'm sending these many ethers or ways, right? So that is a input that I'm giving. Now what is the output that I'm giving here? So here I have got the where is this input to this thing? Okay, it will have the block number also. Yes, that is this ID, which is going to give me the block number of the um, in which this transaction got confirmed. So I will be able to at any time go and check with I will be able to understand that this transaction got confirmed by looking into the block number. Otherwise I will not get a response. Okay, this also I will show you, don't worry, I will show you this one also. Okay, um before we see this dapps, let me show the, 1 minute, let me, before we see the dapps I will show you the demo. This is going to be in I'm doing the session from my Infi laptop. Okay, so that means I'm going to have some restrictions. So I will, but you, when you set it up in your own labs or anything, you may not face those issues. Okay. Give me a minute for me to start that. Okay. Can you see my screen?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. You're still seeing my presentation, is it PPT?
Yes, ma'am.
Okay, no, then no, you're not seeing that one. Okay. My environment is still starting. Meanwhile, I will show you the. So this is the same thing that we saw yesterday, the escrow contract. Okay, so when I say deploy, I will show you that. Wait. So you can see this. I'll open this up. So when I click on deploy, it initiated a transaction. See, you can see this is the transaction hash, that is the transaction ID. Then as a result of the transaction, my output contract address got created, because that is what is the contract. You can see that is also a contract account, right? So that address also looks very similar to our accounts here, right? So that is what it means, that this is an external owned account which holds, it is just an account holding ether, but this account that got created as a result of deploying of this transaction, this is called a contract account. But this contract account has our code also. So if you look at this, see, you can, this is the input that we sent to to create this contract account, right? This hash is going to be the hash of our input transaction. Okay, so now I have got in this doesn't show me the this doesn't show me the block number and all that. Okay, I'll show you that in the node only. This is in a VM. I'll show you. Again, today what I'm going to do is I'm not going to connect to any of the existing global Ethereum networks. Or rather, I'm going to set up an Ethereum network on my standalone in my laptop. Okay. But and again, because I'm talking about only in my laptop, only one node will be there. Okay, I will
Ma'am,
not be able to connect it
ma'am,
to
I
any
have a
other.
doubt.
Yes.
Ma'am, if I sent a transaction to the wrong Ethereum address, then what will happen?
What will happen? You tell me. If you send it to your if you send it to a wrong bank account, what will happen?
It was gone.
Same here, gone. If you can manage to find out who that wrong account is, and request him or her to send it back, then you will get your money back. Otherwise, it will not come back. Okay.
Okay, ma'am. Thank you.
Ma'am, I have another doubt, ma'am.
Yes.
How long does a transaction take in Ethereum platform, ma'am?
In Ethereum, it usually takes a few seconds, maybe around 15-20 seconds.
Okay.
Ethereum it takes, but in the in other Bitcoin network and all, it will take minutes
Okay.
or sometimes even more.
Okay.
Yep. Any other question? Okay, so I'm not going to connect to any Ethereum network. Like I said, I have restrictions from my environment, Infosys environment. So that I will not be able to do. And I'm going to have a standalone Ethereum node. Okay. You can also do that in your own laptops or desktops. I will show you the you can, I'll give you the URLs also. So if you are interested, you can do that. Ethereum. Get the download. Okay, so Ethereum software is available in many forms. Okay, you have Ethereum software implemented with Go language, which is the Get. Okay, then there is Ethereum software done in Python also. Okay, so whichever one you want, you can download. Okay, I will give you this URL. You can, I will ping it in the chat window for you. You can go to this URL and choose. Okay, that is also slow for me. Okay, but anyways, you can go there and choose whichever version you want. It will be something like this. But I have already installed here. I will not install it, but I will show you the. Okay, yeah, downloads. You can see my screen, na?
Yes, ma'am.
Okay. So here you can download the software for whichever OS you are interested in, Windows, Mac OS or Linux OS. This will download the latest version. Okay, if you are looking for any specific version, then you can just scroll down and you can choose older releases and you can download that. It will be an installable. Once you download that, and if you run that installable, Get will be installed in your machine. Okay, now what I'm going to do is I will also open my command prompt and then I will explain to you. Okay, so I'm going to create a node in this path. Okay, when I create a node, there will be some folders created with where my hashes will be stored, where the account key store for my accounts of this node will be stored. Okay, so that is why we have to have a proper directory. So first I have to create the account. This I'm all going to do with command line arguments, commands from the command prompt only. Okay, so Get is the one. I've downloaded the Go implementation of Ethereum software, so I'm going to use all Get commands. Okay, so Get account new. This is a command, don't worry, these are available in okay, let me give you that URL also. Don't bother to note this down. I'll give you the URL. You can go there and I'll give you the complete documentation. From there you can take this. Okay, so this is the official documentation of Get. Okay, so here you will find all the complete guide of help for whatever you want to do in Ethereum with using Get software. Okay, so don't bother to look into these things. I'm going to first create a account for my node. Okay, for my node, I'm just giving a name for my node. So this is going to create an account. So whenever we create an account, it has to ask for a password. The public key will be automatically generated. My password, which is nothing but the private key. Okay, I'm going to give some password. It will not appear there, so you just have to type it. Okay, so now you see this is the public key of the account or public address of the account that got created. Now what got created is actually an externally owned account, a wallet. Okay, so now here I have created the address account. Now with this account I'm going to initialize my node. Okay, I'm going to initialize my node. How do I do that? Get Okay, I have to, when I'm creating the node, right, I have to create a Genesis block. What is a Genesis block? Did we touch upon that? What is a Genesis block? Anyone? I think we did not talk about that. Initial block for any blockchain. Right, so for initial block for any blockchain, so whatever blockchain you are having in Bitcoin or in Ethereum, in which whether it is a private Ethereum network or it is it is the public Ethereum network, it is there are a lot of test networks of Ethereum also, Rinkeby, those are all test networks. So every network, blockchain network, will have a Genesis block, which is the first block, initial block of that chain. All right, then from there only from the next block only is going to get created. But when the initial block is something like a hard coded block. Okay, so that is what I am going to give first. Okay, I am in, this is a developmental node that I'm setting up. So I can give, this account is going to be a dummy account with dummy ethers. Okay, it is a developmental purpose. Okay, so I'm going to create this with this Genesis block where I'm giving the account also. And if you look at this, I'm giving some chain ID. I'm telling this is the block number I should start and all that. Okay, so here I'm just giving a dummy chain ID. If you look at the Genesis block of the actual live Ethereum network, this will be 1. The chain ID will be 1. Okay, so here I am giving a random number which is telling that it is my developmental chain that I am going to work on. Okay, so now with this Genesis block, I have to initialize my node first. Okay, so the node that I want is node A. Okay, I'm just giving a random node here, name for my node, and then I have to initialize it by using this command init and telling initialize it with the genesis.json file, which is what I just modified, right? So I'm giving that here. So you can see successfully wrote Genesis state. Okay, so this is what has got created. My node has got created. Now how do I know? So if you look at this, a folder node A got created. You can see get with the, so it has got created the chain structure, right, to store my chain data, right, and it has a key store also, which has one account only we created, right? That account is account's key store, key value pair is being stored here in an encrypted format. It tells me this is the UTC time zone, time format, and then this is the public address of my key, sorry, account, public key of my account. So this currently this node has only one account in it, right? So now if I go, I have to then now start the node, right? For starting the node, there are a lot of parameters. Okay, so I'm going to give this. So these command line arguments are all there in the documentation. So I have to copy. Yes. So here see, I'm telling Yeah, everything is get commands only. Okay, so I'm telling start this node data directory. I'm giving the folder path. Okay, and then this node has to run in this port. There is an RPC call, that RPC server also, which will be starting, so that has to run in this port. I'm telling for this node, this is going to be the ether base. So if this node runs any minor process, the rewards will go into this account. And I'm giving a dummy network ID here. This is just to redirect all the console. Like this, there will be lot of console statements. I'm just redirecting it to a file so that my console looks neat. Okay, so if I do this, okay, logs I did not create. You What is happening? Just give me a minute. Yes. So you can see that just a minute, let me reconnect. Okay. So now, okay, now I can create more accounts inside this node itself with personal dot. These are all commands that you can find in that documentation only. I'm just creating a one more account. Okay, I'm giving a password for it, private key, and what will get generated is the public key of my account. Okay, so like this, I can go about creating as many accounts that I want, right? We can have multiple accounts in multiple banks, right? Same way, I can do that also. I can have multiple accounts um, in my node. Okay, now what are all the accounts that I have? I can see like this. So I created 3 accounts, right? Initially I created only these, then there are 2 more accounts that I created, right? So now what I can do is I can check the balance of this. One moment again. It is not responding. Give me a minute, please. I'm sorry.
No problem, ma'am. தண்ணி வந்து புரியல. ஏன் சொல்லுங்க. இதை பார்த்துட்டு நேற்று அனுப்பிவிட்டேன். முந்தானத்தை அனுப்பிவிட்டேன். முந்தானத்து நைட்டு அனுப்பிவிட்டேன். ஒன்றுமே சொல்லல, எந்த கரெக்ஷன் சொல்லல. அவங்களே எதுவும் சொல்லக்கான நான் இன்னைக்கு கூப்பிட்டு பேசணும். நேற்று சரி சரி, எனக்கு எது சொல்லல. இது எப்போ கூப்பிட்டு நேத்தா? ஓஹோ, சரி சரி. எனக்கு நான் அந்த கோடு நான் போடல. சுபத்ரா எதை அனுப்பிச்சுடுங்க அப்படி இல்லை, அந்த கோடு தான் எதுவும் போடல. நீங்கள் போட்டீங்களா?
I had to restart the
சரி சரி
VM.
சரி சரி சரி. அது மேலே அந்த கோடு இருக்குது, QP கோடு இருக்குது.
I will.
அப்படி.
Yeah, 1 minute. Just give me 1 more.
ஆஹா. ஆ ஆ ஓ டே சாமி, எப்படி நோட் பண்ணிட்டு இருக்கிறாங்க பாருங்களா. அப்பா சரி, பார்க்க விடுங்க. நீ வேற வரலன்னு சொல்லிட்டீங்களா? ஆ ஆ ஆமா. அதுக்கு ஒன்றும் சொல்லியா?
Okay, while my VM is restarting, I think we will see the rest of the presentation also, so that when my VM is back again, we don't need to lose time. Okay, can you see my screen? PPT?
Yeah, yes, ma'am.
Yes,
Okay. All right. So, see, writing smart contract is what we saw yesterday, right? We saw a smart contract program that we wrote. We executed it with the help of an IDE, correct? Online itself, on the browser itself, and we did it in a dummy environment, correct? But then, how will we actually? Build an application when we are doing it in real time? How are we going to do that? We cannot definitely run it inside an IDE, inside a dummy environment. I can develop, I can test, but when I have to deploy, it has to be in a proper environment, correct? So that for that we have to connect our smart contract onto a actual network. And do you think anybody is going to use this kind of an IDE to okay, here I have to, in this text box I have to give this? Because that environment, how we saw yesterday, is very technical, correct? An user of an application will not know the technology of blockchain, will not understand that here I have to give this many ethers, here I have to give the parameters for the method, I have to, what is initiate contract, what is confirm delivery, all these things the user, as a user of that escrow account, will anybody know? As a bank user, you will not know how to go and operate the bank's software, correct? What you will know is only your internet banking, which is very very user friendly, which I know, okay, I have to do a funds transfer, I have to add a payee, those terms I will know. But will you know that it is a blockchain application or a Java application, or which database it is connecting to, you will not know as a user of that application. So when I am developing an application, I should have a proper front end to my application, correct? I should have a proper user interface, the back end where the processing is going to take place, whether it is in Java server, whether it is connecting to a .NET server, we don't need to know. The front end is just for the user. It is for the user to connect, correct? So now there is so your application will be complete only when there is a front end to your application, and then the processing is happening in the back end. The back end could be any Java code, it can be there will be a database attached to it. So all that, this full thing combined with the front end, with the back end, with the database is what is called as an application, correct? But in a blockchain scenario, with this application is going to be with only a front end, and the back end is what is going to be there. Where is the processing taking? It is taking place in a smart contract. That is your back end. That is where your business logic is going to get implemented. So and where is this smart contract? Is it sitting in one machine? Yeah, no, it is sitting in a decentralized network, in a blockchain network, right? And your front end is also going to be it might be in one of the nodes, it can be in more than one node also, right? So it is a completely decentralized environment. It is so much different from the regular, you are hosting your regular web application, which is going to be hosted in a web server, which is sitting in a specific server. A client server kind of an architecture is different, right? Because the application is going to run on specific servers, and then your UI can be from any browser. That is how generally a client server kind of an application is going to behave. But here in a blockchain application, you see that the front end will be any kind of UI, Angular application, or a React application, right? So these are all different front end. So any front end technology can be used to develop this front end application, and your back end is going to be a decentralized environment executing a smart contract. So this setup of blockchain applications is called decentralized applications. When you deploy a D app in a in a completely open environment like the Ethereum, it is a completely decentralized system. Okay, it is a completely decentralized system. But when you are putting it into a private network, then the setup might be different, but it is still decentralized, and it is still the processing is going to happen in the form of only a smart contract, right? So that is, and the where is all this going to be stored, or where is all this going to be recorded? It's going to be recorded on your blockchain, which is basically your database, right? So this setup of applications is called as decentralized applications. It has to be decentralized because it's not centralized in any server. Then it is deterministic. It is deterministic in the sense because it is in a decentralized environment, wherever given the same inputs in whichever node that I have running, it has to give the same output. Only then it can be, only then it will be a consistently, data which is there in my network, right? So it has to be a deterministic one, and it has to be Turing complete, meaning if it has to be the functioning has to be complete. I cannot leave it in one in a inconsistent state, meaning if there is if it is something like this, commit and roll back. Okay, if there are series of operations that are taking place, if one fails, the entire thing has to be rolled back. Or if everything is fine, then everything has to be committed together in fullness. It has to get executed. That is what is called as Turing complete. And then isolated in the sense it gets executed inside your EVM, right? So your backend has to get executed inside your EVM, which is a standalone environment, but it should not affect your smart contract code. Should be in such a way that it should not paralyze the entire network itself. It should not paralyze the entire network, because there will be there can be multiple transactions happening at the same time. So it has to be executed inside your EVM such that it will not paralyze one transaction. One node is performing one transaction, another node is performing another transaction. It can be possible, but the transactions should be in fullness, and it has to get executed completely, so that when it gets completed, the network will again sync up to come to a same state of information. Okay, so it should not paralyze the network. It should not be something like I'm writing an infinite loop, my node is then going to become totally unresponsive. That cannot happen, right? So you should take care of all those things when you are building a D app. Okay, now there is one more important concept here, which is called as oracles. Okay, so the name sounds familiar or similar to Oracle database, but I don't know why they gave such a confusing name, very similar one, but anyways. Okay, so this is called as oracles. Now, why you need this is, in most cases, my smart contract program, is going to, it's not something that will, for its execution, it will not, may or may not have all the information within the blockchain network itself. Now let's assume I'm having a betting application. Okay, now this betting application will need information from the let's say a share market price, or a game score, or some match information, or I'm having a insurance application, insurance project that is implemented on blockchain. Okay, now this will such that automatically when they hear that there is a flood or natural calamity, in a certain geographical area. Okay, now what can happen is, if I get that information, okay, if I get that there is a flood, then and then the farmers who have taken weather based insurance from that geographical location, instead of waiting for the farmers to file a claim, I can initiate a claim automatically also, right? So there the information, the triggering information is coming from outside the blockchain network, right? How will my blockchain, I am telling it has to be, it is in a sandbox environment, it is a complete peer-to-peer network, it has a Ethereum software, or it has a Bitcoin software, or it has some other blockchain software that is running inside my node. Now how will this node get information from a different execution environment, right? Because my information is going to come from a different system. It is like two systems have to talk to each other. Now how will that happen? That is where you have some things called as oracles. Okay, now oracles are nothing but kind of middlewares, okay, third party softwares which are going to populate information to the blockchain network, or get information from the blockchain network through APIs. Because APIs are nothing but functions that will make two applications talk to each other. That is what is called as API, application programming interface, right? So your oracles here are going to be third party softwares which are going to help either push information into the blockchain network, or take information from the blockchain and do something to pass it on to some other external system. So that is where we have these oracles. They are going to be through API calls. They are third party softwares. Okay, why you cannot write the same kind of code? Why can't I directly call the external system from my smart contract? You cannot, because my smart contract is going to be within the EVM. Now, it is a sandbox environment, right? So I should have something inside my blockchain environment itself, which will give me the information. So that is where I'm bringing this oracles as a third party into my network. And from this third party, which is there inside my network, which can talk to the outside network and give me the information to my smart contract. Okay, so this could be writing to external databases, it could be talking to external applications, it can be for anything. So that is what is called as Oracle. So most of the D apps, when you are writing it for actual business problems, most cases you will be using Oracles also as part of your smart contract code. Okay, so that is why this concept is also important. I'm not going to be able to show you this Oracle demo, but yeah, it is good to know about this. Okay, so let me see if my machine is ready. Okay, this there, and you can see my screen now, the VM.
Yeah, yes, ma'am.
Okay, all right, I may have to repeat the steps that I did a little earlier. Yeah, I will quickly do that. First we created the account, so I will do that. Get account name for my node A. Okay, and I need this account. What happened? Okay, I gave this. Now let me initiate the node. Get data dir for node A and init it with genesis.json. Okay. The next one is a big command. I'm not going to be able to type it, so I will copy it from my.
அது எதுக்கு போடுறீங்க அப்போ ஆஃப் பண்ணி அப்போவே
Okay, and let me quickly new account. Okay, so now in this node I have 3 accounts, so I can see that also here. Okay, now if I have to look into the balance of every account, for that also we have some commands. Okay, so the first account is the one that we created. We created with the dummy balances, right? So it has so much of money, sorry, ethers. Now the other two accounts which we just created after we started the node will not have anything. Okay, so if you see, these two accounts don't have anything. Okay, I'm instead of giving the public key, because I'm querying for it within the node itself, this is like an array and I am using the index 0, 1 and 2 like that. Okay, otherwise you have to give the public key of the account and you will get the value here. Now we will just see a simple transaction to transfer balance from ethers from one account to the other account. Okay, so for that we need the command. We have a command. Okay, I'm going to transfer from accounts of 0 because that is what has balance to accounts of 1, and I'm just transferring some, let me transfer some 50 ethers. Sorry, values here. Let me transfer 50 ethers. Okay, so now if I do this, it will ask me to unlock the account. Which account? The debited, to be debited account, right? Because otherwise I cannot, I have to provide my signature, right? Otherwise it will not get, the transaction will not go through. So I have to unlock this account first. Lock account of my this one. All this is possible because I'm doing it within my this thing. Okay, I have to unlock it. What I gave while creating the account, no, the private key, that I have to type it here. So now it is unlocked. Now I can submit the okay, so I will submit the transaction again. Okay, now what I'm getting is the transaction ID. Okay, now this transaction will still be there. It will not get um, processed because there is no mining happening, right? This is the only node that is there, and this node is still not doing any mining. So if you look at pending transactions, you can see all the details that we sent. See, I gave 50 ether, so it has converted to wei. This is in wei. Okay, the denomination here, and see, from account is what I gave here, this account, then to recipient account is here, right? These are all, this is the hash of the transaction. These are all the hashes of the value that I am passing here. Okay, now what we need to do is have a mining process. Only then this transaction will get confirmed. So again, so when in a proper network, this you will not be doing it as and when needed. There will be a node which will be running this mining process forever, right? Then it will be looking for the transactions and it will quickly keep picking up the transactions. Okay, so I have just started the mining process in my node. Okay, so here it will take some time. I think it will take some time actually. In the meantime, let this because if I still go and see pending transactions, it will still show. Okay, so in the meantime, let us go and keep our contract ready to be deployed to this node. Instead of deploying it to the dummy environment in my remix this thing, right? Instead of that, I will We will deploy it to this node that we just created.
475 and above இருக்கா 10 சரி சரி பசங்க தான் வந்து ரெடியாக தான் இருக்கிறாங்க பேசுறதுக்கு
Okay.
மட்டும் கொடுக்க சொல்லுங்க பசங்க வர்ற பணத்தை வேணாங்கிறாங்க பிஎஸ்சி டிபார்ட்மெண்ட்டுக்குலாம் ஆயிரும் கால்குலேஷன் கொடுக்கலினாலுமே அந்த பணத்தை நம்மளுக்காக கொடுக்க சொல்லுங்க சேலரியாவது ஓகேங்க சிஸ்டர் சதீஷ் அப்புறம் எனக்கு மேலே கையல்வெளி மேம் சதீஷ் 2 பேர் தான் ஆமாம் நீங்கள் கூப்பிட்டு பேசுங்க
Just I have it saved for my for so that I don't have to waste time now. So this is there. Let us compile it. I need to check my compiler version. Okay, so now, okay, so when I compile, I said when we deploy it, what happened? When we deploy it, yeah, a contract account will be created, and there in a contract account we have a portion in the memory which is going to store the code hash, right? What is that code hash that will get stored? Okay, we have two things that will be created as an output of your compilation process. One is the bytecode, which is the bytecode which is understandable by your EVM. Okay, and then there is something called as ABI, application binary interface. Okay, so these are the two things that will get created as an output of your compiling process. Okay, so if you look at the not copied, okay, I'll show you the bytecode here. So if you look at the bytecode, see it has so much, it's all fully in zeros, ones, it's a complete mess which you cannot understand only. Okay, so this is the bytecode of your contract that got just compiled. Okay, and then there is something called as application binary interface. Okay, so what is this is going to happen is, like I said, API means application programming interface, which are the points at which another application can interact with your program, right? So like that we have all the ways in which an external application can talk to this contract. What it essentially means is, what are all the public members here? Okay, so now if you look at this is a public method, this is a public constructor, these are all public attributes. That means I can see all of this. Any application connecting to this contract can get the values of these attributes, right? So these are all the entry points of for any application to talk to your contract. So that is what is there in this ABI, right? So if you look at this, see, current state is one of the thing that any application can query from this contract. So if you look at this, confirm payment is a method, right? It is a payable method. Now what is the type of this? This is giving me the value. Same way, this is giving, it's a function taking some inputs, which is nothing but, here it is a payable one, so it will expect a ether transfer to execute this function. This payable is false, so this is just reading the variable, so it is fine. It doesn't need any ether to be sent to perform this transaction. So like that, it has all the information of for any application to interface with my contract. That is what is this ABI means. So as a compiling output, as a output of a result of your compilation process, you will get these two, okay, which is important for building your DApp. Why am I talking this is, it is important for you to know this for building your DApp. Okay, so we will see that just in a moment. So I think by now the transaction should have got confirmed. Yes. So if you look at Now if we go and look for our balance, right? We have to look for the balance of our accounts. The ETH of accounts of 1, we transferred 50 ethers. So if you go there and see, not accounts of, okay, yeah. So we transferred 50 ethers. Now it got 50 ethers from the other account, right? So now we have same way. Let me quickly also transfer some more ethers to the other account so that we can use them as buyers and seller account in the escrow contract. So here, if you look, let me do one more 50 ethers. Again, I have to pass on. What happened? Oh, my node got shut down. My accounts go because this is developmental environment, right? My accounts, okay, thank God it didn't go. Okay, I have to do the transactions again because these are developmental accounts. It is very slow. Okay. I made it 2 times, I guess. Okay, now let me send another 50 ethers to the other account also. Okay, got it. Okay, so now what I'm going to do is I have 3 accounts in my node with balances, and I'm going to connect from my IDE, okay, to deploy my contract to that node. Okay, so how I'm going to do that is where I'm going to deploy, right? So here I have the environment. So JavaScript VM means I'm putting it into the dummy environment within this browser. But if I connect it through this Web3 provider, it will ask me for the endpoint. What is this endpoint is, remember when we started this node, we gave a port, RPC port, right? So this is the endpoint, RPC endpoint, to which my clients, front end applications can connect to. So here I have to give the port 8102 correctly. So now if I click OK, you can see that I had 3 accounts in that node. See, I've got all the 3 accounts here. I can see them here, right? So these are the accounts. It means my client, which is the Remix browser, is now connected to the node that I just created. How it is doing? It is connecting it through the Web3 endpoint, RPC endpoint that my node is exposing, right? Because that is how my get soft, I have enabled that in my get client, right? When I am starting that node. So now I'm going to give the account, I'm going to give this as the buyer account, let's say, and I'm going to give this as the seller account. Okay, I'm going to give this as the seller account. Okay, and I'm going to deploy this contract to my node. So see, I have got it deployed. I've got it deployed. Now my buyer is nothing but my account from this node. Like you can see that eth.accounts, if I see, you can see these are the accounts, right? Then something happened. Yeah. So you can see this is the account, that is the buyer here. And same way seller is also the same account that is there in my node only. Okay, now what I'm going to do is, yesterday we saw how we could interact with the contract from here only, right? So we initiated the contract from the buyer's account, then we initiated it from the seller's account, then we progressed with the confirm payment, then confirm delivery, all that we did, right? So now what we are going to do is, we will see how I will build a front end to this contract, so that my front end will talk to the contract which is running on my Ethereum node. Okay, so for that, what I'm going to do is, I'm going to write a node application using because my Web3 modules are there, JavaScript APIs. With that APIs, I am going to write a HTML page, a very simple one. Okay, actually you will be writing it as an Angular application like that, but I am making it very simple because then it will be very difficult for me to explain. So I'm going to I'll open that and then I will show you. Wait. Okay, so I have written it all here in HTML only, and I'm using the Web3.js, which is specifically for any clients to interact with my Ethereum nodes. That is the Web3.js. It is a node available as part of the node modules. Okay, we can get it, that also we can get it installed only. So here I am giving the HTTP provider. So I am telling that my backend to this HTML front end is my node that is running on, I gave the RPC endpoint, right? That I have to give here. I have given it as 8102, which is the same as what I have for my node also. Okay, I have already written the code, so I will just take that and make only few changes. Control C. Okay, so This is my contract ABI. Remember, we have to get this. We got this as an output of the compilation process. So I have to tell the because my Web3 has to know these things to connect to the contract. Okay, I have to give the ABI. I have to give the contract address also. What was the contract address? I can take it from here. I can take this from the contract address, and I gave it here. Okay. And then I am getting an object, the contract object using my Web3 API. I am giving the ABI, sorry, Web3 API. I am giving the ABI and my contract address as an input, and I am getting the object of my contract. Okay. Now, if you look at this here, just a minute. I will execute this and I will show you what more changes we have to do. So these things you will know. Let me run this in my browser. Okay, so an application should have user interface, right? So I'm just having this, like I said again, this is very simple. So you ideally you should have a login for the buyer, then there is a login for the seller, and they should give their when they are logging in, you should get their public key and save it, and with that public key you should initiate the contract, right? So I'm just cutting out the login part of it. I'm having them all hard coded in my application here. So when my buyer has to initiate, first step is the buyer has to initiate the contract, and the seller also should initiate the contract, all right? Then only it will move to the next stage of the, then only the status of the contract will move ahead, right? So for my buyer to give, what is the buyer address? The buyer address was this one, right? So I will copy this and I should have this. Ideally, you will have all this as part of the database, and you will not hard code it in the application. So don't go exactly by what I'm doing here. Okay. All the conventions for building your application you should take care of. Okay, that you cannot, that is not shortcut. This is a demo example that I'm showing only for demo purpose. So don't look for conventions here, or when you are building, don't build it like this. Okay. So I have a button where which the buyer will click to initiate. I have a button for the seller to initiate. Okay. Now let us see. And before that, the buyer and the seller's account have to be unlocked. Personal dot unlock. These are all set up that I have to do. Okay, so let me now go to the HTML page and see if I can get the buyer to initiate it. We can see whether that happened or not. Okay, it got initiated. See, when we do this, the status of my message will come here, right? Because my seller also will initiate it. Then if you see the, or wait, F12, were there some errors or invalid opcode? Okay, the contract is wrong then. Let me pick the ABI again, or the address is wrong. Contract account is the same, correct one? Okay, so now let me see if see, you can see that the status of my contract got changed. It is the same as, there is this buyer current state. You can see it is moved from an uninitiated to awaiting payment. Now awaiting payment, how it will happen? Once the buyer confirms the once the buyer sends the price, right, sends the amount equal to the price, then my thing will move from awaiting payment to awaiting delivery, right? So for which I have not added the button here, so let me quickly do that also for you. Okay, so here again I'm just trying to do the bare minimum for you to understand. So buyer confirm payment. Okay, I will. And I should call that method. So these are all using those Web3 APIs. Okay, so whatever you see as the contract being called, the account being given, from which account I should give, all that, right? Those are all Web3 APIs. You will find it in the documentation link that I have given you. So it should go from the buyer's account. So let me give that. Okay, I'm calling the contracts. I should call which method? Confirm payment method, right? So I will give this here, confirm payment. To confirm payment, I am sending the value. It is expecting it is a payable method, right? So I have to send the value ether also, and I have to send it from the buyer's account only. So if you look at the UI now, reload. Okay, I have this. Now if buyer can confirm the payment, then the status would go to 2. So this is how this entire setup, where my front end is in some front end application, and otherwise this is a technical environment where the user is not going to use, right? So the user of the buyer and the seller, actual buyer and the seller who's involved in this application will not understand this interface, right? So you have to build an interface, you have to build a UI for proper front end, and use the and code, do the coding for the front end to connect to your contract, and then execute the transactions. So this complete setup of having your front end with the connecting to your node, Ethereum node, which is going to run the contract, that is called as the D app. Hope it is clear. Did I give too much of information? I hope it is not. You guys are able to visualize and understand how you will be building an application.
Yeah, yes, ma'am.
Okay, so there are some questions. What are the ways to build D apps? See, Dharani, the D apps are nothing but, I said it's a combination, right? So there are many tools also, but ideally the smart contract building is one part, and then your front end building is one part. So front end can be in any kind of any front end technology, right? Like React application or a Angular application, right? You can have a Spring application also. Anything that you have to which for which we have the API support to connect to your Ethereum network, you can build it with that way. Smart contract, again, there are so many languages. You can write it in Solidity is the one that we saw, right? What we saw was the Solidity, which is a very common language for building smart contracts in Ethereum. There is Viper, there is LLL, this one. So if you look at the this thing, right? If you look at the, it has support for many other see, it has support for many of these languages. Learn ETH, so many are there. Solidity, you can have Solidity is the one that we used. So this likewise, you have support from many languages, many tools to develop it in many different languages also. Of course, if you are building it in a different blockchain network, if you are building a Hyperledger network, then there is a different language. Go language is the one that you will use to write the smart contracts. So different blockchain platforms have different languages in which you will write the smart contract in. Okay. Okay, the next question is, what is the difference between DApps and smart contracts? Janani, I told you the DApps is a combination of your front end and your back end. Here the back end is the smart contract. They are not two different. Smart contract is a part of your DApp.
Okay, ma'am.
Okay. Some DApps, Ethereum DApps that are run currently. 1 minute. Let me give you the. Wait. Let me give you a URL where you can see different DApps that are there as open source. You can which are running on the live Ethereum network. I'm not able to find that. 1 minute. Let me give you there are a lot of fun DApps also. There are a lot of useful ones also. Okay, I will try to get you that. I'm not able to quickly get that information. I will get you that, Dhanush.
Ma'am,
Yes.
ma'am, what happens if my internet connection is lost in the middle of a transaction?
If the transaction has reached your node, it is okay. Even if the internet connection has gone, the transaction will still happen inside the Ethereum network. Okay. But if it is not, then the transaction would have not gone to the network at all. So you have to fire the transaction again.
Okay.
Okay.
Okay, ma'am. Thank you.
All right. Anything else?
Students, if you have
Any
any
other
queries,
questions?
please ask.
No questions? I hope you noted down the URLs that I gave you for the documentation and downloading and all. So I think I encourage you to go through those documentations, understand, read more, because what I gave you is very little, which I can which is what I can do in these 2 days, 2 hours of each of these 2 days. But definitely, I think this is a good pointer for you to start on and understand more about Ethereum. Okay. Any questions, please? Otherwise, sir, I think I'm done with what I wanted to show.
Ma'am,
Yes.
can I have that PPT, ma'am, for our...
I cannot share that, Logesh. Let me see. I will check with Roy if there is some way how we share it to the colleges, because it is outside my Infosys network, right? So I will check how I can give that detail to you.
Okay.
Can I any other question? Okay, that's all, I think.
Sure, sir. It is a lot of information, so it's okay. You can take time to process it and learn more.
Yeah, definitely.
Sure. Thank you, sir. Thank you so much
Yeah,
for
thank
this
you.
opportunity.
Yeah, thank you so much. Ma'am, once again,
Sure.
I would like to call upon Ms. Janani for presenting the word of thanks. Before
Yes,
that,
sir.
just a minute, Janani.
Yes, sir. Yes, sir.
Can anybody willing to give a feedback? I expect
Ma'am,
feedback from you, people.
ma'am, it was really an interesting session, ma'am, and we really benefited and we learned a lot, ma'am. Thank you for this session.
Thank you so much.
Ma'am,
Yes.
it was very informative session, ma'am. We learned a lot about blockchain. Thank you for the session, ma'am.
Thank you. I hope you take this learning. You don't stop with what we discussed in these 2 days, and you really try and learn more also. It is a very interesting topic.
Okay, Janani, proceed.
Yes, sir. A pleasant morning to one and all present here. On behalf of the Department of Computer Science and Engineering, it's my immense pleasure to extend a vote of thanks to all those who have contributed in one way or the other for the successful completion of 2 days online workshop on Ethereum blockchain. Heartfelt gratitude to our most respected secretary and correspondent, Thiru S.D. Chandrasekhar sir. We are highly indebted to our respected principal, Dr. M. Jayaraman sir, respected Dean, Professor P. Jayachandar sir, and our beloved Controller of Examination, Dr. K. R. Valuvan sir, for their eternal support. We accord our sincere gratitude to our most respected chief guest, Nityalakshmi Pantacharam, Technology Lead ETA, Infosys Chennai, for giving us an informative and inspiring 2 day session. On day one, your session gave us all the fundamental aspects of Ethereum, its working, EVM, and all the information about smart contract and its execution. In today's session, we have gained insight on building blocks of Ethereum and the implementation of Ethereum network. We have gained many new informations about the decentralized applications. Surely it laid a foundation to learn about this new technology. Thank you so much for sharing your valuable time with us, ma'am, and thank you for clearing all our queries. We thank our HOD, Dr. S. Jabin Begum ma'am, for her valuable guidance. Sincere thanks to our workshop coordinator, Dr. S. Gokulraj sir, for organizing this informative session. We extend our sincere thanks to all the teaching and non-teaching faculty members for their timely support. We thank all the people who got connected with us today for the successful completion of this 2 day online workshop. Thank you all once again.
Yeah, thank you, Janani. Okay,
Sure.
thank you,
Thank
madam.
you so much. Thank you so much, all of you. Thank you for the opportunity. As I'm equally thankful as each one of you here. So it is indeed a very good feeling for me to talk to professors and students, right? It's always a very special feeling. Thank you so much. And yeah, please do. I think, sir, if you can coordinate the feedback and if you can mail it to me, that will be very nice. Um, uh, through mail, that will be good for me also.
Sure,
Thank you so much, sir.
okay.
Thank you, everyone.
Okay, ma'am, thank you.
Thank you,
Bye
ma'am.
bye.
Thank you, ma'am.
Thank you, ma'am.
Thank you, everyone. Can our students leave the sessions?